Okay, this is an exam question. Okay, a lorry P of mass 15,000 kg climbs a straight hill of length 800 meter at a steady speed. The hill is inclined at 2 degrees to the horizontal. For P's journey from the bottom of the hill to the top, find A, the gain in gravitational potential energy, B, the work done by the driving force, which has magnitude 7,000 Newton, and C, the work done against the force resisting the motion. Okay, let's do part 1 first. Okay, first of all, okay, one thing you should remember: work done by driving force, okay, dF, same as basically the difference in ME. Okay, difference in ME, the mechanical engineering, mechanical energy, not mechanical engineering, mechanical energy, plus the work done to overcome the resistance or against the resistance. Against the resistance. Okay, so work done by driving force dF the same as or equal to the difference between the mechanical energy. Okay, we'll talk about the mechanical energy, and plus the work done against the resistance. Okay, what is mechanical energy? Initial KE plus PE minus final KE plus PE. Okay, so since energy is a scalar quantity, so don't worry about the sign. Okay, so initial KE plus PE minus final KE plus PE is the difference in mechanical energy, difference in ME. Okay, difference in mechanical energy. So that's what we're gonna find. Okay, let's start. Always draw a diagram. Okay, always draw a diagram, sketch it. Okay, so let's say I have an inclined plane somewhat like that, and then it says 800 meters, so P is right at the bottom, and the mass is M equals to 15,000 kg, and this is P. Okay, and then it is inclined at 2 degrees, and the distance that it has covered is 800 meter. Okay, 800 meter. So now, what is the gain in potential energy? Okay, first of all, is there any, they've not given us any velocity, okay, for the initial or the final. Okay, so we don't have to worry about kinetic energy so much. So now, okay, initial ME. Okay, when I talk about ME, mechanical energy, which consists of KE and PE. Okay, KE and PE. Okay, is there any kinetic energy? Okay, don't think so because there's no velocity. Okay, and for PE, is there any height at P, at this position here, at at the bottom of the slide or bottom of the hill? There's no height, so there's no PE also. So both gives us 0 joule. Okay, whereas for final ME, what we have here is velocity not known, so there's no KE, plus PE. Yes, we do have, what is the PE? Okay, but mgh, which is the potential energy. Okay, mgh, so M here is 15,000, and then G is take 10, and then what is the height? Okay, we want to know what is the height that is covered. Height is vertical position. Okay, what is that height? So this is same as opposite over hypo, so it is sine 2 degrees equals to opposite, which is, let's say, x over hypo, which is 800, so therefore x equals to 800 times sine 2 degrees. Okay, so plug that here, so 800 times sine 2 degrees, and then use your calculator to find that value. And the answer is 418,793 9 418,793 joule. Yeah, okay, or you can even round it to 40. Okay, doesn't matter, I don't like to round at the beginning, I'll just round it at the end. Okay, now so that's your answer. Okay, so what is the change? Okay, what is the difference in the ME? Okay, if you look at it, okay, for the first question they don't require anything, they just want the gain in gravitational potential energy. So our answer here, the gravitational potential energy here is 418,793.9, or if you want to round that, you can round that to 419,000 joule to 3 SF. Okay, for the next part of the question, the work done by the driving force which has magnitude 7,000 Newton. This is a driving force. The question requires to find the work done. Okay, they are not requiring us to find what is the driving force. They want what is work done. So use the formula. It's only one more question. So part 2. Okay, part 2. Work done equals to force times by distance. Okay, so force here they have given us 7,000 Newton, and then times by distance 800, and what I have here is 56,000,000 joule. Okay, don't forget you have 5 zeros there. Okay, so yeah, that's your answer. Okay, so that's for part 2. Whereas for part 3, okay, so for part 3, work done against the resistance. Okay, work done against the resistance. So this, we already have the formula over here. So this is what I want to find. So all you have to do, work done by driving force, which is 56,000,000 minus the change or the difference between ME. And what's the difference? Initial was 0, final was 418,793.9. So you just have to minus that. So 418,793.9 joule, and from there we have the answer as 1412061 joule, which I can write it to 3SF as 1410000 joule. Okay, let's look at the next part of the question. Okay, part 2. The second loader Q also has mass 15,000 kg and climbs the same hill as P. The motion of Q is subject to a constant resisting force of magnitude 900 Newton, and Q's speed falls from 20 meter per second at the bottom of the hill to 10 meter per second at the top. Find the work done by the driving force as Q climbs from bottom of the hill to the top. Okay, again I would like to sketch a diagram here. Okay, let's say I have Q here, and the mass for Q is 15,000 kg, and V at the bottom of V1 equals to 20 meter per second, whereas V2 equals to 10 meter per second. Okay, and then as Q moves forward or climbs up, there's a resistance. Okay, and what's the value for the resistance? It's 900 Newton. Okay, so I'll just write resistance equals to 900 Newton. Okay, 900 Newton, and again it's the same hill, so it should be 2 degrees. Okay, and I think the distance is also 800, so I'll just put it over here. The distance is 800 meter. Okay, now let's solve the question. Okay, so there's a resistance, it's climbing up. Okay, the mass of the lorry is 15,000. It's going up. At the initial velocity was 20. By the time it reaches the top of the hill, it has gone down and reduced to 10 meter per second. So that's the first thing. So first let's find out the initial ME. Okay, initial ME at the bottom of the hill. So I have KE, which is half mv square, and this is the same as half times by m, which is 20 square times by 15,000, and we have 400 times 15000 divided by 2, and the answer is 3 1 2 3 4 5 6. So 3,000,000 1 2 3 4 5 6 joule. Okay, this is 15,000. Yeah. Okay, so that's KE. Okay, is there any PE? No, I don't think so. No PE. Why? Because it's at the bottom of the hill and there's no height. Height equals to 0. So therefore PE is also 0. Okay, so that's our initial ME. Okay, initial ME meaning at the bottom of the hill. Okay, now final ME. Okay, let's look at final ME. The speed has reduced to 10, so KE equals to half times by mv square, which is half times by 15,000 times by 10 square. So that's 100 times 15,000 over 2. Let's look at it. What's the answer? That's 750,000. 750,000 joule. Okay, and is there a PE? Okay, yes, because it has reached a certain height, certainly there's PE. Okay, and this is the height, so certainly there's PE. So let's find out what's that. So PE equals to mgh. So m equals to 15,000 times by 10 times by h. Okay, h here is like what we did earlier. It's sine. Okay, this is sine 800, sine 2 times 800. So I'm going to replace that sine 2 degrees times 800. Okay, so let's find out what do I get here. And the answer is 4187939. I'll just round it to 40 joule. Okay, 4187940 joule. Okay, so now add the KE and PE to find out what is the total final ME. Okay, when you add this two, you get 4187940 plus 75000. Okay, 1 2 3 4, yeah, 0 joule. Okay, use your calculator, and I've got 4937940 joule. Okay, so this is your final ME. But now you have to find what is the difference between both ME. Okay, you have to find what is the difference both ME. Okay, we have seen the question here. Okay, work done by driving force equals to the difference in ME, okay, plus work done against the resistance. So in this question, what they ask us is to find what is the work done by driving force. So we have that. So first, but we haven't got what is the difference. So to find the difference, so we take 4937940 joule minus 3,000,000 1 2 3 4 5 6 joule, and the answer is 1937940. 1937940. Okay, and now plus with work done against the resistance. What is the work done against the resistance? Okay, we have 900 Newton. I think we did this before. Yeah, okay, work done against just okay, no problem, we can still find. So this is 900 Newton. Okay, work done. So plus 900, W equals to, oops, W equals to FD. So this is 1937940 plus F, which is 900, and then multiply by 800. Okay, so 1937940 plus 900 times 800 is 72. 900 times 800, I think 720,000. 720,000. You add those two, 1937940, you get 2657940, and this is in joule, and this is the work done by driving force. Okay, so work done by driving force is 265, or I can round this to 3SF to 266, 1, 2, 3, 4 joule.